Hello world, Lee here from Ruby Gold. Today in this episode we'll be going through an exercise on the Ruby track on exercism.org. I believe today this video is the assembly line. So we're still in the early days of going through the Ruby track. So we're still picking up some beginner concepts. We haven't gone into anything too deep yet. If you've been watching this video series, but we're introducing a new concept today. Let's see. I'll keep the preamble brief for this episode. We're just going to be going through, trying to find a happy path through the code to find a solution that works. Then we'll review perhaps a few other community solutions. But yeah, so like I said, keep the preamble brief, and let's hop on over to exercism.org. So Ruby track, this is actually, I'm looking at this page, and perhaps this has been here the whole time, but I don't remember seeing this previously. That could just be me not paying attention, but I think this is kind of cool. See this live on Exercism. Somebody attempted an exercise. Let's just reload the page, see if those a minute ago. Yeah, okay. So I wonder, it's kind of curious. I wonder if you watch this, how long it would take on average to see that change, what days of the week exercism is more popular. Actually, those are interesting statistics. I wonder if they keep track of. But yeah, no, just cool little thing. Nice way. Like I said, maybe it's always been there. Maybe I've missed it. But if it's new, it's a good example of how the Exercism platform continues to receive constant development and get a lot of tender love and care. So this video is the assembly line. So we're going in this order basically. I think this is pretty similar to the suggested order here in practice as things get unlocked. You can see it's still a learning exercise. It's not even an easy category yet. If we look at the syllabus here, this learn map, we can see that, let's see, I think it's down here in numbers is the assembly line. So numbers, integers and floats. We're learning Ruby, and as you should know by now, Ruby is not a strongly typed language. Ruby is a dynamically typed language, and numbers are a pretty good example of that because our variables, could be different. Numbers, floating point numbers, so on and so forth. Being a dynamically typed language, a variable could very likely change from a string to an integer to a float in various different ways. So maybe we'll see some of that in numbers, maybe we won't. But as we continue these introductions to concepts in Ruby, we might start to see some things that make Ruby stand out, especially if you have experience with other languages, what maybe makes Ruby different or similar to those languages. And if you have no other experience and Ruby is your first language, welcome, congratulations. And it's good to, just still get the basics in what Ruby is and does. Anyway, I was going to keep the preamble brief, so let's get into it. We'll start in the editor here. And so, just take an initial glance at what we've got. We have an assembly line class. It initializes an instance variable. And we've got two methods that we'll be implementing. So if I run the test, just do my basic check here, we should see, we've got quite a few tests, 15 tests. So that's kind of interesting. I wonder what they all are. I'm going to assume that those 15 tests are probably going to be handled pretty much by these two methods. So probably a fair split, 7, 8 tests per method implemented, perhaps. But we'll carve away at them one by one and see what we get as a final result. So all of our tests do fail. Everything blows up. That's what we expect to see. That's what we like to see from the beginning. And our expectations are met. So if you've been following this series, you know that we're going to see our first method should most likely be failing because of this raise here. And that's what we see here in the test error. Please implement the assembly line production rate per hour method. Also, a little introduction here. If you are new to this series, we sort of go into these exercises a bit naively. I don't read the instructions. I leave that to you to read on your own. And certainly if you're learning Ruby, you should be reading through these instructions. There's a lot of important information. I like to tease out the results from the tests themselves and see. Sometimes it leaves me scratching my head a little bit when I shouldn't be, because I don't read those instructions. But I think it's pretty fair that we can tease it out, treating the tests as the requirements. So the first thing we can do is, of course, change the error message. So right now we're getting the error message, please implement this. If we delete that, we get different error message, and all tests still fail. And so, yeah, we can see here, nil can't be coerced into float. Well, that's kind of an interesting one. So we can see that the assembly line object was instantiated with 1. And then we call production rate per hour, which we get nil. So I think probably this error here is based on the way the test is written. And I know I grumble about this a lot in my videos. I really wish I could see the tests. It seems like when I'm not doing these videos, the tests are available to me, and when I'm filming these videos, they're not available to me. An alternative is I could download these tests, the whole exercise really, using the Exercism command line client. It's a really nice way to approach these, because then you actually can load everything in your development environment. Maybe you have certain plugins or configurations. Maybe you're using something bare bones like Vim. Whatever the case may be. And if you're more comfortable in your development environment, then you can load these on the command line and run the tests. And with that approach, you can absolutely see the tests. But anyway, I think what's probably happening here is because the test is probably implemented in a way that compares the expected result, which would be a float, against nil, which is what we're returning here. So the fact that we have a 1 and we have a nil is simply because we don't have anything implemented here. So I know this is pretty explanatory on the basics, but we just want to make sure that we're looking at the right things, that our tests aren't running. So if I did something along the lines of, and disclaimer, I will be making a lot of typos. I am in the process of switching from a QWERTY layout to a different layout. It is not necessary as a developer. It is just something I want to do, optimize for a lot of keys and key combinations to be on my home row. You can ask if you want more specifics, but that's all I'll say in this video. So probably here, I have a suspicion that I'll probably pass a few tests simply by returning speed. Production rate per hour and speed are clearly not the same thing, but I want to see a little bit more errors to kind of get a sense of what I'm actually implementing here. And this is where the instructions would be pretty clear. The instructions would probably tell me like the basic math behind this. And we might look at that in a moment, but I just want to see first what I get back if any tests pass simply with this. No, okay. So that was actually a little bit of a naive assumption. It seems like we're moving away from the very basic exercises to exercises we have to think a little bit more about what we're putting into our methods. But we can see that in this case, here we got an expected versus a comparison. So this is cool. So we expected 221 minus 1, this, I guess, to be less than or equal to this. So, all right, the first test is production rate per hour for speed 1. Okay, so we're passing that in. Per speed 2, let's look at the way that these tests are written. Yeah, so we're expecting, okay, and then speed 3, speed 4, speed 5, speed 6, speed 7, speed 8, speed 9, speed 10. Well, interesting. We have 10 tests that are just testing speed, different speed numbers. There's some debate about whether that's necessary. My guess is that we probably, because this is an introductory exercise to numbers, we probably just want to see a variety of different numbers here. In a real world environment, we'd probably be testing for different bands or ranges or something a little bit different. We probably wouldn't test 1, 2, 3, 4, 5, 6, 7, 8, and so on. But let's see if we can sort of figure out what's going on here. So production rate per hour for speed 1. So essentially we're getting a number and we're expecting that 1 so production rate per hour at speed 1. So something like, let's see if we can piece this through. And this would be a comment. Let's see. So let's think about what we have. 60 minutes is an hour. And because we're working items per minute, I'm thinking that's probably the unit we're working in here. So essentially, we're going to get X items at speed 1. You know what? I am going to hop over here because I don't want to twiddle my thumbs for too long here trying to figure out what's going on. All right, so implement this to calculate the assembly line's production rate per hour, taking into account its success rate. Oh, interesting. Success rate. Note that the value returned is an instance of float. All right, I think I do need to read the instructions because I can't really, I'm having trouble piecing that together. I think I need to understand what the success rate is. And so that's something where the code alone here, bare bone structure, doesn't seem to indicate enough information to me. So in the real world, this would probably be the understanding of what your product is, what your company does, what your production is, et cetera. So this would be your domain knowledge, your specific company knowledge, something like a success rate. So let's take a read. Analyze production. Yep. Assembly line speed can range from 0 to 10. So that's probably something about why we're testing each of the 10 speeds. So maybe in this case we do need to test each of the 10. Perhaps. We'll see. It kind of comes down to ranges, but we're not really modifying the test, so it's not really up to us. So at its lowest speed, 221 cars are produced each hour. So, yeah. That leads me to think that we can probably cheat and pass the first test. Let's see what happens. Yep, okay. So we were able to cheat here. And let me break this and see what the output was again. Yeah, so it's okay. That's kind of interesting. So we're expecting 221 minus 220 to be less than or equal to this. So 1 should be less than or equal to that. I'm still not quite understanding this test. But we can see that 221 passes this test. And so likewise, if we come back here, 221 cars are produced each hour. The production increases linearly with speed. So 221 times 2 is going to be 442, right? So this should pass test 2, but not test 1. Okay, so that just means, x times speed times 221. So let's actually take that in here, right? Speed times 221, right? So we're sort of piecing together some information here. We kind of get the sense that speed times 221. So this should actually have a high chance of passing several tests. Okay, so we get some tests to pass, but not all, which means, again, there's information buried here that we don't know yet. So maybe this 221 is not going to be consistent. Maybe something changes at a certain speed. We've got a few things to figure out. Let's continue reading here. However, higher speeds increase the likelihood that faulty cars are produced, which then have to be discarded. Okay, so that's why, things are changing. So it's not always going to be 221. I think that's something. So let's see. The following table, 1 to 4 is 100% success rate. And we saw that consistent with our tests. All 4 of those first tests passed. And it's when we get a higher speed that our success rate starts to drop. So what we kind of know is that this whole thing here is going to be, is going to have a modifier on it. So I suspect if we test a theory here, let's see the 90% success rate if we can pass tests 5 through 8 by essentially running this against a 90%. And it blows up, and that's kind of fun, and there's reasons for that. Okay, so let's look at why this blew up. I didn't like the fact that, so if we read this, it didn't like the format here without having a 0 before the dot. And we run that again, and we see 4 tests pass, and they're 5, 6, 7, and 8. Okay, so we kind of understand, if we group these things differently, let's see what happens if we group it like this. What happens? Does that pass any tests? And it does. So that's sort of a math property, right? Because we're multiplying by multiplying by multiplying. In theory, the what is that? The associative property, or I am not a math major, but there's some property here of mathematics that says it really doesn't matter which thing we group, and in theory, because they're all multiplication, the order of operations doesn't really matter. So potentially we don't need to group them at all. But when I do mathematics, I do sometimes like to group things, and it sort of shows us that we have like some piece of knowledge here. Like, what is this 0.9? The 0.9. It's what? It's, success rate. So probably we need something that determines a success rate, and potentially we need a new method for that. So there's other ways to think about it. Maybe our success rate isn't going to be a method. Maybe our success rate is a constant. But because our success rate is variable, right, probably a constant doesn't really make sense, right? Yeah, I mean, if you just think about it out loud, constant and variable. So I'm saying variable here, not in the sense of a computer programming variable, but in the sense of it will change, which is sort of like drawing the distinction because of like arguments of mutability should variables actually change. But, constants, whatever. But we know that we're going to, so it's not that it's going to change, right? Success rate under the conditions is always going to be 100% or 90% or 80%, right? So you could get like really tedious and be like 100 success rate. I mean, we could do it, but you still have to have a way to figure out which one to use. So probably a method here is going to be a little bit more useful. And it's going to be something like under cases where we have a certain speed. So where speed, let's see, do I know how to write a case statement? So you could do if and else, if statement. So this is going to point us to if statements. I don't want to do if statements. So I'm going to search. Let's see. I need to. So with a case statement, you're going to have like specifics, right? So you can. You can think about an if statement, right? If speed is 10, 77 is our success rate. If speed is 9, 80%. If speed is, else if, right? And it gets tedious. We know these are preset ranges, and I want a case statement to lay them out specifically. So let's just do Ruby case statement. Okay, yeah. So here, I'm guessing this is probably right. I actually should be looking at Ruby docs for this. Case X, so speed, when 1 to, oh, that's okay, yeah. I kind of like this. And then else would be your default, right? So if you're not familiar with case statements, instead of an if statement where it's if, else if, etc., we're giving it specific cases to look for. So to avoid yeah, okay. When look, now it suggests it. All right, and then here it would be things like 1 to 4. And those little dots, right, are inclusive and exclusive. So I always forget 2 versus 3. We'll see what happens. So when this, we're doing 100%. When now I'm getting autocomplete suggestions. Why wasn't I getting that before? Okay, so 5 to 8, we want 0.9. When 9, we want 0.8. And else. So here we could either do an else for the default, but I don't really think default is right. Honestly, I would say if there is a default, it would probably be, if you really were going to argue for a default, it would probably be your speeds 1 to 4 with 100% success rate. But even that, I don't think we can really work with. So we could do like an else and, I don't know, raise an error or something. Invalid speed, something like this. Yeah, so, all right, let's think about what we've got here. I don't know why these are indented separately from, whoops, that's not the right button. Indented separately from, oh, you know what? I think I'm using trying to use a keyboard shortcut that would not do what I expected to do in the browser, but it would work fine in my editor. Okay. So I think typically case statements are indented like this. Okay. Well, so we wrote some code, and before we go any further, I think we want to test the code. Let's see what happens. So we passed 9 tests, which is interesting. We didn't pass 10. Yeah, so that should be pretty obvious. Hopefully you already see the problem here. The 10th one failed to run because it returned invalid speed because we forgot to type our 10th case here. But that was interesting. We saw that this worked and it raised an error. We may or may not need that. We may or may not want that. It probably, ideally, we would have a test that makes sure that the speed is within the range that's appropriate. Because the implementation would probably be, if you think about it, there'd be like a dial or something that's like limits the speed selection from 1 to 10. And so like we could make the assumption that we cannot get a speed outside that range. Those are, again, things you have to know. You have to understand like what you're building and what's possible. Do you need a test for that? Is it an assumption that you can actually make? Probably you would think just make a test for it. It's low cost, and then you have the extra control. So probably a test would be more valid here than having an else, but we're going to run with that. We're going to leave it the way it is. All right, cool. So minimal understanding of what's going on. We still were able to pass 10 tests, and we're in pretty good shape. And then we see, so our next set of tests here starts to work with the working items per minute. And it looks like we're going to solve the rest of the tests with this method. So again, we can remove that raise and get a different message. All right, so we expected a number. So remember up here, we were actually getting floats, right? So we haven't even really talked about floats, right? Here we have float conversion. So we could actually be explicit on the off chance that like, let's make sure that passes. It still does. So because we're being explicit down here with floats, we probably want to be consistent and call this as a float to avoid a type error where somehow 1 doesn't return a float and blows up elsewhere. Now, because it's a dynamically typed language, Ruby will often, if our code is pretty good, pretty straightforward, it will often give us what we want. And it's kind of nice, honestly, to not have to think about it too much. And frankly, depending on what you're building, you really might not have to think about it too much. Probably you're going to see bigger differences between things like strings and numbers. But that's, those are things that you learn in the long run. For now, we're just going to be consistent and give it floats for floats. I just want to run this real quick. It should fail something, and it fails the test 4. Okay, so yeah, so I alluded to this earlier, 2 versus 3. So 3, I believe, ends up, your range is 1, 2, or 3, stopping before 4, whereas this goes through, so keeping that at the 2 was the correct way. So with 2 dots, it's inclusive of the ends 1, 2, 3, and 4. Okay. And I think this is pretty clear overall what's happening here. I do, I think my formatter, my default formatter will organize these in line with the case and end, but I kind of like, the problem is that else, because the else is typically in line with, I am going to go back. Okay, I'm going to stick with it this way. I think this is what my default linter would normally do, and I kind of like the argument, the else in the end being aligned is pretty common. So we're going to stick with that. Okay. Tedious things, I know, but we're going to run with this. And that's why linters and formatters are nice, because oftentimes you can write it how you write it and then just run the linting over it and get the formatting that you like. All right, moving on. Let's see what we have to do here. So a cheeky test here, right? Get 3, and it does pass this one. So if we return a float versus an integer, so it looks like there was automatic conversion happening, or the test simply wasn't specific enough. Maybe the test was written in a way that test converts from 3.0 to 3. And this is where maybe my understanding of the exercise sort of falls apart, because interesting. They're showing you some puts debugging, or well, debug. Oh, interesting. I've never used this here on Exercism. Well, anyway, production rate per hour. Nope, this one. So it's telling us specifically that it returns an integer, and this returns a float. But it doesn't really seem like these exercises actually care about that. That's kind of curious to me. Maybe it's my lack of understanding on what these are supposed to be doing. Okay. But if we look at the test, so we're just going to work with this one. So it was speed of 5 and 16. It might be actually easier to look at the one that's here. Falls within that range because it's 100% success rate. So it passed in 3. So the speed was 3. And we got 1 working car per minute. If you think about that, so the success rate was 221. I still have to do some math. So yeah, what do we got? 221 divided by 3, I guess, right? So, okay, we can sort of intuit from this. Yeah, probably you don't see what I pulled up on the screen. So 221 is our base rate per hour. And if you divide that by 3, it's 73 and repeating, blah, blah, blah. So essentially you can see it's a little over, it's over 60 cars, but not 120 cars. So it's just thinking this through on principles, right? In 1 hour at speed 3, we produce more than 60 cars, but not twice 60 cars, right? Which 60 because 1 hour is 60 minutes. So a little over a car per minute, but not quite 2 cars per minute. So completed cars would have to be the lower bound there, and that's 1. So that's kind of like how it's deriving in this case 1. So the same idea here is if we look at the test. So speed of 5 is going to have a 90% success rate. So again, you can't see my calculator. But if we have 221 and we divide that by 5, well, it would be times 5 and then times 0.9. So that would be 994. And then if we take that and divide that by 60, we get a number that shows it's just over 16 right, 16.575. So the intuition here is that we get essentially 16 cars per minute, because at speed 5, we're able to do times 221 times 90%, and then that's your per hour, and then divide that by 60, and it's a little over 16, but again, we have to do the lower bound. And so that's what we get. So this is an integer. This is where maybe the type comes into play, because 3.0, well, all right, let's say, so we're trying to do, yeah, so for the first test, 3.0 is fine. What happens if we do 3.1? Okay, yep. So it was easily able to coerce 3.0 into 3. Right, 11 tests will pass. But it cannot coerce 3.1 into 3 because this is a float and it has a value. So probably this is going to say something about maybe, yeah, here we go. It's going to have some coercion things. So things like rounding down to the nearest integer. So this, okay. So yeah, what I wanted to do was essentially this, but that's not going to work because it's going to blow up because you can't like, I think it's going to, no, it didn't blow up. Interesting. You can actually chain a method on a float like that. That's something I don't think I've ever done. I don't think I would ever do it's just, I mean, really it's because you have a magic number here. This is just like, I'm just trying to test I'm just trying to check the test and see what it does. But it's kind of funny that that works. And what I was trying to do is essentially this is what we're doing. We have a float and we're trying to call the floor on it. So really, if you think about it, we have a float, right? This returns a float. So if I just replace this, we have a float and we're calling the floor on it. And this makes a lot more sense. We're not using a magic number. We're using a method here. So probably that might be what we need to do. Well, actually, it doesn't really break anything. It doesn't really do anything. Yes. So it fails test because that's not fully what we do here. I was doing the math earlier. So taking our hourly rate and dividing that by 60 and calling the floor on that, right? So that works. That works. I don't really like it. What if we change this? We take that and divide that by 60. Does that order of operations hold up? It does. It's a little cleaner because, like, whether we're dividing the total amount by 60 and calling floor on it versus the hourly amount floor and then dividing by 60 probably doesn't matter. I leave that to the math majors, people who are really good at math, to figure out. But this is a little bit easier to read. So like, how many full cars did we produce per hour? Yeah, they're cars. Right, so I think I like this better. How many full cars, right? That's what we're trying to do here. Full cars, completed working cars in 1 hour. And then we're dividing that by 60. And this 60, yeah, and this 221, these are kind of like magic numbers. 60 is a little easier to intuit what it means. 221 is a little harder to intuit what it means. So I think probably in this case, I will actually define some constants. So we've got a working solution. Now we're going to clean it up a little bit. That's kind of what I'm doing here. And so it's red, green, refactor. That's your test-driven mentality. Red, green, refactor. Tests fail, then tests pass, and then you make the code actually decent. Because oftentimes your first code would not be particularly decent. So I'm going to have something like a base rate. Is there a term here? Let's see. At its slowest speed, 221 cars are produced per hour. The rest of this is probably just Ruby explanations. So, yeah, I don't know. Base rate, base cars per hour. You could play around with the language here. I might tweak it a few times. Regardless, base cars per hour. I mean, it's really a base rate that's modified by the speed. So the slowest speed is like the minimal of what can be done. The basic, right? It's probably like one machine working or one set of staff working, or whatever it is. So base cars per hour is 221. It's not the best name to give this constant. Speed times base cars per hour. I don't even know that I need base here. Cars per hour. I'm going to leave it like this. That should now, replacing that magic number with the constant should be fine. And this is one that, like, okay, arguably this may not be necessary. It feels a little tedious, right? Minutes per hour. Like, come on. We know there's 60 minutes in an hour. Working items per minute. Right, so could we just do minutes here? Minutes per hour. Working items per minute. I kind of want it to be a little bit more generic. So minutes per hour. If we were going to work with this and like try to figure out, carve our hour up into like 15-minute segments, we could just do minutes per hour times 4, right? But what if we had another way that was like minutes per segment, per shift, per minutes per time block? I'm not going to use any of those right now. I'm just going to use minutes per hour. I don't love it, but I'm gonna run with it. And honestly, because it's like one of those definitions, it's one of those definitions that, like, why are we defining this? There's probably a Ruby, like a Ruby minutes per hour There's probably like a built-in there's probably like a basic way to like use Ruby methods to get that without us defining a constant. But let's say we did want to change it to 15 minutes. We want to find out how many cars. So yeah, so that's where like the name kind of falls apart. But you could at the same time, you know, times 4, right? Right, for clarity, I'll put the parentheses there. Like, so if you wanted to find out like, okay, how many working items, and again, this would be a different method. So it would probably be like, if you really needed this, you probably won't. It's, items per quarter, I don't know, a quarter of an hour, right? Quarter. So probably like, I'm really belaboring the point here. Right, you would probably end up with something like this, and it would be fine. 15 minutes. We know that 15 minutes, well, that 4, right? So probably don't want that, but this would give us your 15 minutes. Anyway, I'm belaboring the point. It's really not necessary. I don't love this name. I probably would think about this differently if this were a real project I was working on. But it does pass. That's fine. We could also add our adder reader here. Right? We could do something like this. That should still pass. Honestly, it's probably not necessary. I'm just going to put a space between those. Whether you put the constants first or the outer readers first is, there's probably some valid reasons for one or the other. This feels a bit long, but it's fine. Let's submit this. We've got a working solution. It's in pretty decent shape. Let's submit it and just see like kind of what some other people are doing. Maybe we can get a better name for these constants. No immediate feedback, that's good. My iterations. So I was trying to find in a previous video I was trying to find like what my iterations match, and I did see it after the video on some screen, but now I don't know what screen that was. Was it if I continue an editor again? Well, it was somewhere. I'll probably find it again after this video and forget to mark it down. Let's see what people have by most submitted. So interesting. I don't know if fewer people do this exercise or if solutions just vary a lot more. But the most submitted is only 16. I believe in other exercises we've done so far in this series, the number has been like 100, 200, 600. So let's look at a few of these and see what they're doing. Nothing drastically different. They defined a success rate case above. So they specifically changed it to I. That's interesting. So in this implementation, it's probably accurate. It's just basically going to drop the. So I'm gonna challenge you to look at what would be the difference between the way we did it here and the 2i. So a floor versus a 2i. Is there a difference? Does it do anything different, right? Like pull up an IRB console or something. It's interesting that they did it 2i here, but they didn't like coerce this into a float. 16 submissions. I like that variable name, hourly yield. Number of cars. What do we do? Cars per hour? Hourly yield I kind of like. Let's look at this solution. So one thing I want to point out is here they have some control over making sure that a speed between 1 and 10 is given. So that's a way to do that. Yeah, so they still have that 60 though. It's interesting. Again, like working items per minute, you can sort of reason out why it's 60. I just don't like it. Yeah, so sticking with 1. What is this? This doesn't seem like it would be different. Cars assembled per hour. So this person wrote their case statement on fewer lines of code. So it's a when-then sort of a layout, which I think is pretty good overall, but I don't love the else, right? If you're going to do this and format it, like, I kind of like, yeah, I don't love it. Let's see if this person, when then. So no else. What was the else here? So they skipped the 10. And they specifically call out 1, 2, 3, 4. 1, 2, 3, 4. Yeah. So this person did not use constant at all, right? So it is fewer lines of code because of this, like primarily because of this. Interesting. So they put it right in the method. I don't like that. Don't do that. That method's too complicated. You have to don't do this. Please don't do that. Let's see if we can find something interesting. Did anyone else put the minutes into? Here someone didn't add a reader like I did. I'm trying to see if anyone else put minutes as a constant. I'm not seeing that. There's a lot of varied solutions. They're probably here. They're probably like small differences. This is an example of the if else. Although again, so this if is right here in the statement. And it's essentially defining a local variable that's then being used. So this would be a good place to start. It would be fine to start. I would like to see this person do some mentoring and get some, a further iteration on it. Like if they wrote this to start, that would be fine if they're just trying to figure it out and then they extract stuff, right? And that's what furthering. Like I wouldn't want to see it submitted like this in a pull request if I was reviewing it, but I would be okay with seeing it submitted. Like if I was pairing with this person and they started there, if they're a junior, I think that would be okay. Just before you submit it for code review, some cleanup is necessary. But it's an interesting example, and it definitely has, they're working with it. So it's fine. I'm happy that person submitted that. Here was another one. So the difference here is this person, their conditional returns inline the whole thing. So instead of declaring a variable of success rate, they're just returning, which arguably is slightly better, but I really just don't like an else statement here. I've sort of largely come to the idea that like nested ifs and if else's and using a lot of else's, I'm not keen on it. What did this person do? They use return statements. So they specifically do return. This is like a mathematics it's again, it's a fine place to start. I know I threw some parentheses in there while I was playing around, but like, so they have strong conversion to, they're coercing everything to the type they want. But this is this looks daunting. This looks like something, if I came to this down the road to modify this method, it looks daunting. Now, these return statements are really unnecessary because like in an if statement, you can only return the one, like you can't return two. So it's kind of unnecessary. They don't have anything else going on. Right, so like if you didn't meet any of these conditions, there's no else statement here. If you didn't meet any of these conditions, the code could still run, and so those returns might be necessary, but there's no other code, so those returns are kind of pointless. Again, I'm against return when you don't need it. Okay, so we looked at some solutions. I didn't really see anything else that I want to incorporate. I don't know. Let's see what fewest lines. Wow, look at that. 4 lines. This is so this person is solving this, creating a solution in a very different way. I don't think really looking at this is useful right now, so I'm not even gonna. Huh? Why don't I don't know why it's not showing. I think this is bad. Well, okay, so they had some. So this person seems really keen on initializing everything. These are instance variables? That has like some interesting. So they ended up creating a hash. For the speed relation. This is like curious to me. And then they look up in the hash. Yeah, well, it's interesting to see what they've done. I don't really like it. But this person probably didn't come here to learn Ruby. They probably came here to like solve this in a unique and clever way. Some of it seems somewhat unnecessary. Right? Write easy code. Write code that you're gonna know what it's doing down the road. But here's another example. So this is an interesting concept. I don't like this because there's a lot of embedded knowledge in here. Like, what are why are we repeating these? But it is an approach. The lookup table, the hash was a little bit better because you know like you're passing in a value and getting you're passing in a key and getting a value back. I like the hash better than the array. And it's not bad. If you're approaching this problem learning Ruby, I really don't want to see a solution like that. I see what they're, okay, yeah, I see what they're doing. Yeah, I get it. It's concise. I don't hate it, but I don't love it. Well, anyway, that's probably more than enough. We looked at some solutions. Let's go back to ours and see if maybe there's something we can do. So we did see yield, hourly yield. So base. Hourly yield is nice. Base cars per hour. I feel like it's ever so slightly more approachable. So this code is long, 33 lines of code, and a lot of that's because of our case statement. So maybe maybe we can try the when then, right? So people are going to yell at me about the alignment of this, and that's fine. If you want to align your thens, go ahead. I don't really do that so much anymore. I know when I first approached Ruby, like aligning things was like everybody did it every time they could. And it's not like so much done anymore. It actually can like sometimes make things a little bit more difficult to read and tedious to work with, and like formatters will argue about it. So I don't know. Let's is it? I don't know if it's valid to have a then. No, it's not. So we reduced the lines of code, and I would argue this is still quite readable. And I think I like this better. So we're not going to change any constant names, but I do. This adder reader in this exercise, this solution is probably completely unnecessary. I don't really need it, but I'm going to do it. I'm going to leave it this way anyway. It's really unnecessary. It adds some code and some complication. It's really not necessary. And yeah, so like here, because my first pass through, I didn't even change that. Yeah, it's fine. It's unnecessary, but I'm going to leave it anyway. Okay, we're not changing any constant names. We did reduce the number of lines of code by making this more concise. It's still readable, and I think I'm pretty happy with this. So we'll run it through one more time. We're not going to get any automated feedback, and we are going to mark this as complete. So unlock some new exercises. I'm going to return to the exercise. It's possible that what happened was I'm really curious to see where it was that I was able to see my solution compared to other solutions. Well, whatever, it's fine. We have completed the exercise. We have published a solution. Okay, so possibly we're not seeing any others because this is the only solution that matches. So no one else matches mine. That's probably what's going on here. All right, cool. So we've passed the assembly line. We're in pretty good shape. And I'm not entirely in love with this solution. As I spoke about, there's a couple of things that I could debate. I could go back and forth on. I might change team dynamics. What our team considers the right way to do this might dictate some of what I do here. The actual complexity of a real world project might change a little bit about what I have done. Even now looking at it, like I don't know if I would group these with parentheses. That was something I was doing as I was working on it, but there's, it's not a perfect solution, but we didn't set out to have a perfect solution. We set out to find a decent solution, work through the code, find a happy path to a solution. As we saw, there's a lot of variety on this exercise. Pull this back up. There's a lot of variety on this exercise. The number of most submitted, the submissions are not large numbers. There's, it's probably very small variances, but there's a lot more variance here than we've seen in some past exercises. So overall, I think I'm pretty happy with my solution. It was a good exercise. We talked about some things, and so I hope you appreciate this. I hope you learned something. I hope if you were struggling with this exercise that you are able to see a way through. And if you did follow along, I would encourage you to tweak some stuff. Your final solution submitted to Exercism doesn't have to be like your perfect best solution. You can experiment with some stuff, pass the tests, maybe pass the tests with changing some of your methods. And, if you don't like what you come up with better, then you can revert to your best and have that your final submission. I also would encourage you to take advantage of the mentoring. You'll definitely get a lot of value out of the mentoring. So really do that. Never be satisfied with Exercism. It's an exploration of code, right? It's a learning journey. I try never to submit just one solution. I want to have like a working solution, and then I want to have some modifications, because although like we don't ever have to write, there is no such thing as perfect code. Square quotes. Perfect code doesn't exist. Good code is code that wants to change. And so with Exercism, I very much like to have a working solution and then some refinements. And I do like to draw inspiration from what other people have done. So do that. If you got inspiration from me, let me know like what specifically helped you, because that would be helpful, and I can try to consider that in future videos to sort of provide those pieces that are more useful to you. But yeah, if you're watching this on YouTube, please subscribe and like the video, and share the video. Why not? If you're watching it on Exercism, you'll see, it'll be in the Dig Deeper. Sometimes I record these videos and there's a bit of a lag between submitting them and when they actually get it added on Exercism. But any kind of support by subscriptions or likes or comments or shares or anything you can do is very helpful. It encourages me and gives me the motivation to continue these videos. So I very much appreciate your time. Yeah, and so anyway, this was a fun exploration. We're always looking for the happy path through our code. And remember, there's gold in them there rubies.